Okay, here we want to see some questions on error calculation. So we are given if A equal to 1.2 plus or minus 0.1, B equal to 2.0 plus or minus 0.2, C equal to 105 plus or minus 5 times 10 to the power minus 2 centimeter. Find the following with their correct units and associated percentage error. We're only interested in percentage error, okay? I think that's quite easy. Let's start with the I. Now from the I, we have, we can say let Y at all. So let Y be equal to AB over cube root C, square root of C cube. If I should substitute value, my A is 1.2 times my B is 2.0. 2.0 now divided by square root of C cube. C is 105 times 10 to the power minus 2, then all cube. Okay. Now I can find that directly using my calculator. So we have 1.2 times 2.0 now divided by the square root of 105 times 10 raised to power minus 2, then the brackets cube. Okay, so that is giving us sorry, made a mistake with my calculator. Correct that quickly. Okay, sorry, I'll have to perform that again with my calculator. I'm having issues with my calculator. So 1.2 divided by 2.0, then we have square root, open the brackets, and we have 105 times times 10 raised to power minus 2, close the bracket, then all is raised to power 3. Okay, so I get 2.23. So the whole of this is giving me 2.23. Okay, so but we have a question. We're asked to find the percentage error. So that's where the work is. How do we find the percentage error? Now, since y is ab over c cube, we see multiplication, we see division, we see power. So we can say that dy over y is equal to dA all over a plus db all over b plus 3 over 2 times dc all over c. Okay. Now y3 over 2 square root of c cube also means c raised to power 3 over 2. So that's why we have that. Now if we substitute the values, dA over a 1, 0.1 all over 1.2, then plus we have 0.2 all over 2.0, then plus we have 5 times 10 to the power minus 2, minus 2 now divided by 105 times 10 to the power minus 2. Okay, so if we use our calculator, plus 0.2 divided by 2.0, then plus 5 times 10 to the power minus 2 divided by 105. Okay, So we are going to get 0.23. So the whole of this is giving us 0.23. Okay, 0.23 is the relative error, which is the y over y. To find the percentage error means we just multiply by 100. So the answer is simply 23%. Okay, this is beautiful. Now let me rub off so that we can see the next one. The next one has something that looks like square root of a squared plus b squared. That looks quite scary, but is not, shouldn't be impossible. Okay, but first of all, what is y? Our y is equal to square root of a squared plus b squared. So that means we can say that the y is equal to the change in a squared plus b squared all raised to power half. Okay, a squared plus b squared all raised to power half. Raised to power half, the square root here means raised to power half. Which sorry, it should be dy. Okay, changing that. So based on what we have, your error in y, the relative error in y should be equal to half times the error in a squared plus b squared, okay, all over a squared plus b squared. That's what that should be. The error in a squared plus b squared all over a squared plus b squared. Okay, so what is the error in a squared plus b squared? Okay, okay, so how do we find the error in a squared plus b squared? Of course, that is supposed to be some work, but I can give you a shortcut here. Error in a squared, first of all, let's put it this way. So when I say error in a squared plus b squared, we can say it's the same thing as error in a squared plus error in b squared, okay? And all over a squared plus b squared. That's allowed, which you can still write as half times. Error in a squared can be written as 2 times the a, okay? 2 times the a. Or you can put it 2a dA, just differentiate. By differentiation can do that for us, so we can say 2a dA, that's allowed. Then error in b squared will give us 2b dB. Okay, everything all over a squared plus b squared. Beautiful. So at this point now we can substitute our values. So that means I'm going to have half, then times 2 times a, that means 2 times 1.2. Okay, dA is 0.1. Sorry, having some issues. Then plus 2 times b is 2.0, so 2 times 2.0. Okay, I'll just leave it as 2. Then dB is 0.2, so we have 0.2. Okay, now divided by a squared plus b squared, that means 1.2 squared plus b squared is 2.0 squared. 2.0 squared. Okay, so let's find out with calculator. Okay, so I have half. And multiplied by we have 2 into 1.2 and plus, okay, times 0.1 and plus 2 into 2, then times 0.2 Okay, so we have divided by 1.2 squared plus 2.0 squared. Okay, my answer is 0.096. So everything here gives us 0.096. But we're interested in the percentage error, so multiply by 100. That will give us 9.6%. That's beautiful. Okay, so we see the second one. We see the second one. The last one. We can start by saying let y be equal to b cubed minus c cubed all over a. Now my b is 2.0 cube minus c cube. C is 105 times 10 to the power minus 2 cube. Now divided by a. My a is 1.2. The good thing is that we can calculate that straight with our calculator. So we have 2.0 cube minus, okay, we have 105 times 10 to the power minus 2, okay, which is also cube, and all is divided by 1.2. Okay, so we get there 5.7. So all of that is giving us 5.7. Now let's go ahead to find the percentage error. Of course, to find the percentage error, find the relative error, then we can multiply. So from what I can see there, we can say that dy over y is equal to d change in b cube minus c cube all over b cube minus c cube, then plus as the numerator, then change in a over a, that's error in a over a. Okay, so what is error in b cube minus? So we can still write this as dy over y is equal to error in b cube minus error in c cube, okay, all over b cube minus c cube, okay, plus error in a over a. Okay, so we can still do something here. What is error in b cube? I think I've shown us that we can say this is the y over y is equal to error in b cube means 3b squared times error in b, as after differentiating b cube, that's a way to go about that. Then minus error in c cube should be 3c squared, then dc, okay, all over b cube minus c cube, plus of course error in a over a. Okay, so we can now proceed further by saying if we substitute values now, we're going to have, okay, I think I will leave you at this point to substitute values. Please substitute values and let me know what you get at the option. Remember that your final value should be multiplied with 100 to get a percentage error. Okay, thank you very much. Thank you.